to Easy Elim, Learning Simplified. My name is Ruth, and today we are going to be learning on the topic structure of the atom and the periodic table. And our subtopic for today will be balancing equation. So this is a continuation of what we have been discussing in the previous lesson. So we started on how we write simple chemical equation and balance them. And so today we are going to look at other equations. We're going to make them a bit more complex and see how you can balance them. This is a very core topic in chemistry. You need to know how to write equations. And you'll notice as we move on in the syllabus, you require us to be writing equations that are balanced all along. So you need to be able to understand this. So for today's lesson, we'll continue balancing equation, but now you're going to be looking at some complexes one, and then you get to do more practice. So we said for a chemical equation to be correct, you need to have correct formulas on the reactant, correct formulas on the product. They need to be separated with an arrow, and then you need to have correct state symbols. And then after that, we balance it. And we balance so that we can get the equal number of atoms in the reactant and equal number of atoms in the product. So you start with this reaction. So when sodium hydroxide reacts with sulfuric acid, and we call it sulfuric 6 acid, they form sodium sulfate and water. Sodium sulfate and water. So let's write the word equation just like we did in the previous lesson. So it is sodium hydroxide so this reacts with sulfuric acid to form sodium sulfate and water. So this is our reaction, our chemical equation, not chemical word equation. So we are going to convert this into a chemical equation. So sodium hydroxide is written as NaOH. We did this in the video where we are talking about making the chemical formulas of simple compounds and polyatomics. So go and check that out. Plus sulfuric acid. Sulfuric acid is written like this. It also inform one work acid base and indicators to form sodium sulfate. So sodium sulfate also is in the previous topic of forming compounds. So it becomes sodium. It becomes like that. Check it out and see how we did that. And water. So next, we calculate the number of atoms in each side. So there's a trick I want to show you in regards to this equation. When you look at this equation, you can see sodium hydroxide, sulfuric acid, sodium sulfate, and water. When you pay close attention to the sulfuric acid, you can see a sulfate. You can see the same sulfate being repeated in the product. So whenever you see such kind of a polyatomic ion being repeated both sides, you do not have to separate the ions. Like you say sulfur and then oxygen, that becomes a lot of work. What we are going to do now, because you have noticed it appears in both sides, we are going to put it as a whole in our calculation of the atoms. So this is what I'm saying. So the number of sodium atoms is 1, as you can see. Our oxygen atoms is 1. So I'm just going to pick this oxygen atom alone. And then hydrogen is 1. When we go to sulfuric acid, the number of hydrogen atoms, there are 2. So we need to add that. So the total number of hydrogen atoms we have are 3. And then the sulfate, instead of separating sulfur and oxygen again, what we do, we pick the sulfate as a whole. So we write SO4. And you can see we have one radical. That radical is just 1. There's no bracket. When we go to the other side, we have 2 atoms of sodium. And then we have also 1 radical of sulfate. You see there's no bracket involved. And then hydrogen, we have 2 atoms. And oxygen, we have 1. You see how I've separated? Let me rearrange this again so they can look side by side together. So we put the oxygen, also oxygen is 1 this side, hydrogen are 2, and then sulfate is 1. I wanted to put them this way so that you can see them side by side clearly. So our sodiums are not balanced. Our oxygen is balanced, but our hydrogens are not okay, and our sulfates are okay. So the purpose of putting them this way, you can see our hydrogen, we have a total of 3 atoms in the reactant and 2 atoms in the product. This is not balanced, and also our sodiums are not balanced. So how do we balance them out? So first of all, we will start with the sodium. We have 1 atom in the sodium in the reactant and 2 atoms in the product. So what we do, we make the atoms in the reactant to be 2 as well by multiplying by 2, a coefficient. So where do we put these 2 coefficients that we have multiplied with? We place it on the compound where sodium is. When you go back to the equation, the sodium is in sodium hydroxide. So we put the 2 in front of sodium hydroxide. But now this interferes with the equation. Initially, we had this 1 hydrogen. Now it's 1 oxygen. Now it becomes 2. You can see that. And our hydrogen here, which we had written 1, now becomes 2 because we have to multiply it by 2. So our total hydrogens becomes 4. So let's see what has happened. Our sodiums are 2. Our oxygens becomes 2. Our hydrogens becomes 4. They become 4 because this hydrogen here becomes 2. So 2 plus 2 becomes 4. So this interferes with the whole compound. So let's see what changes we can do on the product to ensure that they go hand in hand with the changes that has happened. So sodiums now are okay. But if you look at our oxygen, it's not okay. So how do we make this oxygen to be fine? We multiply this by 2. Where do we put this coefficient we have multiplied with? We put it where the oxygen atom is. The oxygen atom is in the water molecule. So we will put the 2 in front of the water molecule, not on just oxygen, in front of the compound. This affects the whole compound. So let's see how it affects it. So these 2 multiplies with these 2 to form 4 hydrogens. And then these 2 multiplies with this 1 oxygen to form 2 oxygen. So this balances everything out. The sodium reactants are 2, products they are 2. Oxygen, they are 2 this side they are 2. Hydrogens are 4, this other side they are 4 as well. Our sulfate remains as 1 reactant and 1 in the product. So our equation is balanced, but it's not complete. Let us make it complete. So our sodium hydroxide is a solution. We did this in Form 1. So it is aqueous in state. Reacts with sulfuric acid, which is also aqueous in state, to form sodium sulfate, which is also aqueous in state. And our water, which is liquid in state. And this is our balanced chemical equation. You can see it's a bit more, requires more work in comparison to what we did in our last lesson. So let's do another question. So zinc reacts with hydrogen chloride to form zinc chloride and hydrogen gas. So we have our word equation will become zinc will react with hydrogen chloride. This one is hydrochloric acid. To form zinc chloride and hydrogen gas. Next, we convert this to chemical equation. So it becomes zinc plus hydrochloric acid is written as HCl to form zinc chloride. It's written like that. You can go and check how we did that in the previous videos. to form hydrogen gas, which is also diatomic in nature. Next, we calculate the number of atoms in the reactant and the product. So zinc, we have 1. Hydrogen, we have 1. Chlorine, we have 1 from what you can see. And then in the product, we have zinc 1, hydrogens, you can see there are 2, and chlorines are also 2. So you can see our zinc atoms are balanced, but our hydrogen and chlorines are not balanced. We need to balance this out. So we can make a change on the chlorine or hydrogen. Either way, it's going to cause the same effect. So let's start with the hydrogen. We have 2 hydrogens on the product and 1 on the reactant. So we need to multiply this by 2. So we have brought in a coefficient. So we need to place it on where the hydrogen is. And the hydrogen is in the compound called hydrochloric acid. So we don't just put in the hydrogen, we put it in the whole compound. So we put a big 2 in front. This affects the other atoms in the compound. So we have 2 hydrogens, but it also affects this chlorine. So the chlorine atoms become 2 in return. And this balances the equation. So next, we finish the equation because it's not complete. So it becomes zinc, which is solid in state, it's a metal, and hydrochloric acid, which is aqueous in state, it's an acid, to form zinc chloride, which is aqueous in state, plus hydrogen gas. You can see from the name, it's gaseous in state. And this is balanced. Let's look at another example. So this is a bit different from what we have been discussing. This is a displacement reaction. The interesting bit about this displacement reaction is because of the polyatomic ions. This is where the concept and the trick I gave you in the first example comes in. So let's see how we write it. It's already in word equation. So our work is to convert it into chemical equation. So sodium chloride is written like this. It reacts with lead 2 nitrate, which becomes like this. Check out in the previous videos, we did this. To form lead chloride, which becomes like this. And sodium nitrate, which becomes like this. So the first thing that we do is identify the atoms. But now, if you look closely, you'll notice a polyatomic that is repeating itself in both sides. The nitrate. Can you see the nitrate? We have a nitrate in the bracket and a nitrate in the sodium nitrate. So you take it as a whole. You're not going to separate the nitrogen and oxygen. So when you calculate the number of atoms, you start with sodium. In the reactant, we have 1. Chlorine, we have 1. Lead, we have 1. Usually look at the superscripts, the subscripts that is. And then nitrate, we said we would take it as a whole. And it is in a bracket with 2. It tells us that we have 2 polyatomic ions of nitrate. So there are 2. And then in the product, we have lead. We repeat the same way. Sodium is 1 as well. Chlorine, you can see it's in a bracket with a 2. So there are 2 of them. And then lead is also 1. You can see the subscript is 1. And the nitrate is also 1, as you can see, there's no bracket involved. So let's see, our sodium is balanced, chlorine not balanced, lead balanced, and our nitrate is not balanced. So the first thing that we can do, we can start balancing the chlorine. So let's balance. So you can see we have 2 chlorines in the product and 1 in the reactant. So we can change on the reactant by multiplying by 2 with a coefficient of 2. So we need to put these 2 in front of where chlorine is, and the chlorine is in sodium chloride. So we put 2 in front of sodium chloride. This affects the whole compound. So our sodium amount also changes to become 2. So you can see, yes, we have balanced our chlorine, but our sodium has been affected. So we can go ahead and balance the sodium we just affected. So to make it also 2, we multiply by a coefficient 2, which gives us 2. So we place this coefficient we have balanced with in front of the compound where sodium is. And the compound where sodium is sodium nitrate, so we put a 2 in front of sodium nitrate. This affects sodium and it also affects the polyatomic ion. So we have 2 sodiums, 2 nitrogens, and 6 oxygen. Basically, we have 2 polyatomic ions of nitrate, so this becomes 2 as well. And as this balances the whole equation, it's not complete. Let us complete it. So this becomes sodium chloride is aqueous, reacts with lead nitrate, which is also aqueous, to form lead chloride, which is solid in state. You learn this later on in Form 2, when you'll be looking at salts, and then plus 2, this is solid state, and then plus 2 sodium nitrate, which is aqueous in state. And this balances the equation. So that brings us to the end. There are more equations out there. You can go and check them out and try to balance them and see if you can be able to use the same concept. So that brings us to the end. See you in the next session.